Welcome children for class 10 CBSE board lecture 2 topic optics. Now children, already I have taken one class lecture 1. Now lecture 2 topics I am going to teach you. It is taken for image formation. You know there are two spherical mirrors, concave and convex. Today my topic is how many rays you must take to construct image formation by concave and convex mirror, identification of mirror, how can I identify plane mirror, concave mirror, convex mirror, and where mirrors are used. As for example, I am telling you where you can use concave mirror and convex mirror and different types of image by concave and convex mirror. Now one by one I am going to discuss with you. Already you know, in the case of concave mirror, in the case of answer 1, suppose this is the principal axis, this is the pole P and this is C. Any line passing through pole of the mirror, it is concave, pole of the mirror and center of curvature. These two lines is known as center of curvature or principal axis. Now pole to center of curvature, that is R, and half of this radius of curvature, that is known as focal point. So FP will be PC by 2 or R by 2. So focal point FP equal to R by 2. I shall prove it later on. So there are 3 points you consider. One is pole, other is focus, second one is center of curvature. Now any day, suppose any day you consider a ray AB is the object, or you can consider AB is the object. Now generally this concept you must use. Any ray parallel to principal axis AB, after deflection they pass through the focus. This is the condition. A ray parallel to principal axis will pass, concave mirror for pass, THR will through focus. This is the one ray you must consider. Another ray which is making some obliquely incident at the pole, suppose angle I, same angle they will reflect. They will reflect at the same angle I. This is ray 1, this is ray 2. Again I am telling, any ray obliquely incident at the pole making some angle I with the principal axis will reflect with I. Now children, these two angles are same. Another ray you consider, I am drawing again. Suppose a ray, it is a pole, this is the center of curvature, this is the object. Now any ray passing through the center of curvature will retraces back, ray 3. So consider 3 rays generally. One is parallel to principal axis, after deflection they pass through the focus, or any ray passing through the center of curvature retraces back. Where these any two rays meeting and you draw perpendicular on the principal axis, you are getting the image. So you consider it is AB, suppose you consider one ray passing through the focus, second was making some angle I obliquely incident at the point P, reflected back. If these two rays are meeting at a point A prime, you draw perpendicular on the principal axis, you are getting the image. So it is very clear. I think when I am considering image formation by concave mirror, we should treat these 3 rays for our convenience. Okay. So now again I am telling one ray parallel to principal axis after reflection passing through the focus. One ray you consider. Second ray obliquely incident at the pole making some angle I. We reflect at the same angle. Where these two rays meet, you from the meeting point draw perpendicular on the principal axis to get the position of the image. Next, I am considering identification of the mirror. This answer already done. Identification of mirror. You consider suppose the mirror 1. Suppose a mirror is given to you. First, what will you do? A mirror, suppose a mirror is given to you. You hold the mirror very close to your face. Suppose if the image size and object size, face size and image of the face is same, whatever position of the mirror may be, then it is the plane mirror. At the same time, in the plane mirror, you are getting lateral inversion. P is you are getting reverse P. Again, I am telling, if this mirror same size as that of the object, then your face size and image of your face is same, whatever the position of the mirror may be, you are getting the plane mirror. If it is a concave, if it is this is the plane mirror, size of the image not change. Plane mirror, size of the image equal to object size. Now children, if it's concave mirror, if you hold the mirror very close to your face, then you are getting a erect enlarged image. As you take away the mirror from your face, you will get the image of your face enlarged, no doubt, but inverted. Then it is the concave mirror. Again I am telling, if it is a concave mirror, then if you to hold the mirror very close to your face, you are getting the very enlarged, magnified, virtual erect image for your face. Once you take away the mirror from your face, you are getting enlarged image, but it is inverted in position. But if it is a convex, then image size will be very small, whatever may be the position of the object may be, but it is erect. That means for concave mirror, first you are getting erect image, that is virtual. You are taking away the mirror from your face, you are getting magnified image, but it is inverted. But for convex mirror, if you hold the mirror in front of your face, you are getting very diminished erect virtual image, whatever may be the position of the mirror may be. Thank you. Next, I am teaching you. Again, I am telling you how can you identify the mirror. Case 3. First, you hold the mirror in front of very close to your face. If the image of face and image of your object is same, that is a plane mirror, whatever may be the position of the object may be. First case. Second case, if it is a concave mirror, then you will see erect image very magnified when the mirror is held adjacent to your face. Now gradually you take away the mirror from your face. What will you see? You will see the enlarged image but inverted position like this. Then it is concave. If it is a convex, then you are getting diminished erect virtual image, whatever may be the position of the object with respect to face may be. This condition is you already got. Now my question is use of mirror. Now use of mirror, first you consider a mirror where suppose this is the concave mirror. I am giving you, this is the focus. If you give a bulb here, a bulb at the focus, then so many rays at the bulb, these are the incident ray. So this ray after reflection will be parallel. So it will go to infinity. So you are getting a parallel beam, reflected beam. This condition generally used in the searchlight and headlight of a car. So first this condition headlight and searchlight. This condition is used. Bulb is kept at the focus. This is the focal point. Bulb is kept at focus. Now incident ray after reflection from the concave mirror, you are getting a parallel reflected beam. This means beam is going far away from the source. You are getting this principle used in the case of searchlight and headlight of any car. Second example I am giving you, in hospital, ENT doctor and dentist, they are holding the mirror very close to your affected area, and as a result this mirror will produce a very highly magnified image and whole system is easily visible for the doctor. That means ENT doctor and dentist using concave mirror, they are holding the mirror very close to the affected area and they are getting very clear, vivid, magnified image of that affected area. Now similarly saving mirror and makeup mirror, and saving mirror also used. Saving mirror used concave and makeup mirror. When this mirror is held very close to your face, then your face will be enlarged. Then it is very easy for you to save. Similarly, makeup mirror. Another mirror you can use also. Suppose you are considering a concave mirror, parallel beam incident on concave mirror. You know, at the focal point, the parallel beam after incident, they will be reflected and meet at the focus. So they will meet at the focus. This principle, this is sun. This is suppose sun, parallel beam coming on concave mirror. After reflection, they are meeting at a certain point. So whole solar energy will be concentrated at the point focus. So that point will be hot. So this principle used as a solar furnace. In solar furnace, you are using a concave mirror. Parallel beam from the sun incident on the concave mirror. After reflection, they will meet at the focus. So whole solar energy will be concentrated at the focal point. So this is principle used in case of concave mirror. Now my question is, where concave convex mirror is used? Convex mirror. Now then I am telling you, convex mirror. Suppose these are two mirrors. Convex mirror I am using. Suppose there is a bulb. Now this is the incident ray at the focus. So they will be, so this is the focus. So they will be diverged. So field view, this is the field view, increase. Now this is the convex mirror. To increase the field view, we are getting this type of convex mirror. In shops, convex mirror used. But if it is a plane mirror, you see, if it is a plane mirror, then this is the incident ray, this is the reflected ray, this is the incident ray, this is the reflected ray. So field view is less than in the case of plane mirror. It is the plane mirror. Field view less, field view minimum. So in the case of street light, we are getting a bulb and we are getting a very vast area are illuminated with this of convex mirror. Field view is large. In the case of street light, we are using this type of principle, and shops also we are using convex mirror. In convex mirror, always we are getting very small image, that is erect, that means virtual in nature. So as a result, field view area will be very high, large. So again I am telling, to get better field view, we are using convex mirror. Street light, I am giving example. That means in that case very high area we are getting, vast area we are getting this type of mirror. Street light and shops we are using to get a better field view. What type of image is formed in convex mirror? I am telling you, convex mirror image is very small. As a result, area of the field view will be large. Thank you. Now, children, this is the topic I am discussing with you. Use of mirror I have told. Now, image by convex, concave, and convex mirror. Now, children, one thing I am telling you. Convex mirror always producing convex mirror, that means for convex mirror, that is convex. Then outside is bulging. This is the principal axis, this is the object. Now you are considering two. They are going focus. Suppose they are going to focus. Now this is the reflected they are giving. This is the image. So in convex mirror we are getting very small size image. Whatever generally image is formed in between pole and focus. It is the pole. It is the pole and it is the focus. So image is formed in between pole and focus. Now if the body is from infinity to pole and focus, whatever may be the position of the object, we are getting always erect and virtual diminished image in case of convex mirror. Again I am telling, for convex mirror we are getting diminished virtual erect image for all position of the object. Always remember, as a result we are getting very small virtual image, that is diminished, erect and virtual. You remember always, if the image is virtual and virtual, generally they are erect. Now I am considering, that is very important, that image formation by concave mirror. One by one I am considering image formation by concave mirror. Image one by one, image formation by concave. First case, you consider draw a concave mirror. One by one I am considering. Example I am giving you. This is the pole and this is the principal axis. This is the center of curvature. Clear? Now there are different positions. Positions I am considering object at infinity. Number 2, object beyond C. Then object at C, center of curvature. Then object C to F, center of curvature and focus. Then object at focus. Then object F to P, pole and focus. 6 different positions of the object you can take for concave mirror, and you are getting different types of image. Generally for all cases you are getting inverted image, that is real in nature, and only one case, you always remember, only one case when the object is in between, pole and focus. In that case you are getting the A and B, you are getting the erect virtual image. So again I am telling you, for concave mirror, if the object is placed in between pole and focus, you are getting erect and virtual image, only one position. Now one by one ray diagram, I am considering ray diagram condition. First, consider any ray at infinity all incident ray taken as parallel for our convenience. Another is going through the center of curvature. This parallel with the principal axis, this ray will pass through the focus. We are getting the image at the focus. That means you are considering these two cases. Again, I am drawing you. First, you draw. It will be better for you. That means any ray parallel. To consider parallel, you consider. Again, I am telling you consider parallel ray. Two rays are equal to 1 and it is 2. After that, they are meeting at the focus. That means parallel incident ray after deflection from the mirror, they meet at the focus. So we are getting very diminished and real image, because real image is formed after deflection. Rays are meeting at the focus, so we are getting the real image and diminished size at the focus, which is the position of the image, diminished in nature and real in size. Okay. Next, you consider 2. This is the mirror. One by one I am doing. Now this is the principal axis, this is the pole, this is C, this is F. Now you consider AB is the object. This is AB is the object. That is the object. Now object is taken beyond center of curvature. So how you will draw the picture? Now in that case also you are getting diminished image. The first one ray parallel to principal axis you take, okay. Another ray through center of curvature you draw. That will retraces back, and this center of curvature you draw perpendicular. That is A prime. B prime is the image. That is the image. In that case you are getting image, no doubt, but image is diminished, inverted, and they are formed in between center of curvature and focus. Again I am telling image. Where is image is formed? Image is formed at C to F, inverted. Number 3, real image always inverted, real image, and diminished. This is the characteristics of the image. Always remember, children, diminished. That means when I am asking you what is the characteristics of the image, first to draw the ray diagram of the mirror, and then you tell where the image is formed, what is the nature of the image, that means inverted or real, and enlarged or magnified or diminished. Diminished is small in size. So this is the case 2. Now case 3, that means center of curvature, you consider center of curvature. Now body you take at center of curvature. That means C, this is F. You consider AB. So parallel ray you take. This is F, and this is the center of curvature. It traces back. That means in that case you are getting image at center of curvature. One thing you always remember, here AB and A prime B prime, they are the same inside. That means in that case you are getting an image which is same size as that of the object, and but inverted, formed at the center of curvature, and you are getting this type of image. So at the center of curvature if you place the object, then image is formed at the center of curvature, and size of the image equal to size of the object. Next, you are considering case 4. That means there is a mirror. This is the F, this is C. You are considering this is the position of the object in between C and F. Now consider there are 2 cases. First case, you consider parallel ray. Another is passing through the center of curvature, and this is the So you are getting beyond C and F. You are getting one is parallel after reflection, another is passing through the center of curvature, then it traces back. Or this is F and that is C. So we are getting magnified image. A prime B prime, we are getting magnified image beyond C. Clear? Beyond C. When C and F you are putting the object, you are getting enlarged image inverted beyond C. Okay. So this is the case. Always remember. One ray. This is the second ray. After reflection, they are passing through the focus. This is the focus. So two rays meeting at the point A prime. Let us draw perpendicular. We see the size of the image is larger than the size of the object, but it is inverted, not erect. So it is real in nature. Next, we are getting object at this is the pole, this is F, this is C. Now object is at focus. Very interesting. Then what do you do? You draw one parallel, another is center of curvature, another is focus. So they are producing infinity, very large magnified image formed at infinity. If the object is focused, then we are getting very large magnified image inverted in nature at infinity. So this is the case when the object is placed at the focus. Next I am considering the object is at pole and focus. Now object is in between pole and focus. So always you remember, again I am considering, revision class will follow me. This is the pole, this is the F, double of this is C. So this is the object. Children, always remember, object is placed left hand side of the mirror. It is general norms. So first to parallel, then another is through the center of curvature, which is parallel, that is passing through the focus. If you take it reverse order, you are getting reverse, you are getting that is the image. So it is clear from the picture that if the object is placed in between pole and focus, you are getting erect virtual image. Virtual image is obtained behind the mirror, not same size as the object. We are getting magnified, inverted, virtual, and behind the mirror. This principle is used as saving mirror, behind the mirror. Clear? So children, today in our class I have tried my level best to draw picture for convex and concave mirror. In general concave mirror there are 6 different positions of the object where you can get the image. First case I have told you, if the object is at infinity, that means sun or star, you are getting the light generally very at a distance object when the light coming taken as the parallel beam. Then they will meet at the focus and diminished image you are getting. Then you are getting beyond C, then you are getting the inverted image in between C and F. Then at C, then you are getting the image at the C point, again inverted. But C to F, you are getting magnified enlarged image beyond C. Then at F, you are getting the image at infinity. Then F to pole or pole to focus, you are getting only for that case when the image object is in between pole and focus, you are getting enlarged magnified virtual image obtained behind the mirror. This principle is used by dentist and ENT. When the mirror is placed, object is placed very close to the mirror, that means in between pole and focus, we are getting the magnified enlarged erect image. Thank you. Children, again I am telling you, this is the part 2. Gradually, lecture 2, in this way I shall complete your optics part, those that are appearing for any competitive exam, and details I am going. So today rays taken for image formation I have done. There are 3 rays you are considering. One ray parallel to principal axis, after reflection pass through the focus. Second ray, any ray obliquely incident at the pole, they will reflect at the same angle. Third ray passing to the center of curvature, that means along the normal, they retraces back. These 3 rays are used. Then I am telling identification of the mirror. Again I am telling you that if you hold the mirror very close to your face and you see the image same size as your face, then it is the plane mirror. Whatever may be the position, changing the position of the mirror, you are getting the same type of image. Now children, consider if it is a concave mirror, if you hold the concave mirror very close to your face, you are getting very highly magnified erect image, virtual in nature. As you remove the mirror from your face, you are getting gradually inverted image. Okay, inverted image. But if it is a convex, then image will be very small in size, always erect, whatever may be the position of the object may be. Generally, convex mirror image is formed in between focus and pole, whatever may be the position of the object may be. Thank you. Now children, it is I am talking you, or I pray for you that you will do better in this subject. If this is my channel, Roy Physics, helping you any way in the long run, then I am expecting from my dearest ones that they will subscribe my channel to encourage me. I hope they will do so. Thank you. Next, I am meeting you next video, lecture number 3.